Hello, everyone, and welcome back to Pachehra Talks channel. And today we are going to talk about design for Azure Functions, the next topic in designing for compute. So let's explore Azure Functions a bit first. Azure Functions is a serverless application platform. We all know that. We can use functions to write code and without worrying about the infrastructure, VMs, maintenance, and things like that. Just focus on the business logic. Function provide intrinsic scalability because it's serverless. As long as function is running or compute needed, Azure gonna provide it. And you'll be charged only for the resource used. So this is the basic concept of functions. Functions provide compute on demand in two significant ways, like serverless or non-serverless. Yes, it's not always serverless. You can choose your compute prior to developing the code. What I mean by that, you can run in a different hosting plan as well instead of consumption plan. So these are like two different ways. You can run on the consumption plan, and then you can run on the other, like premium and dedicated, or ASC as well. You can run the function on AKS as well. So there are multiple ways you can run your Azure function, and you need to choose wisely as per your application, or the requirement why you're using the function will decide that. So now we know, like refresh the memory about the functions. So the important thing is we need to know where we can use the functions scenarios. So let's check out a few scenarios here where we could utilize the benefits of function. Well, we can run code to upload a file, or change in the file on the blob storage. It might set the notification. Just an example, a scenario, example. Implement an endpoint for your web application using HTTP trigger. Chain a series of functions together using durable functions. We can run custom logic when a document is created or updated in a Cosmos DB. Execute code on predefined time intervals to do certain tasks. So there could be many scenarios where we could utilize the benefits of Azure Functions. So let's explain this scenario in order to grab the idea. Azure Functions are best when handling specific definable actions triggered by an event. This is what the idea behind creation of or the invention of the Azure Functions. So for example, as you see in this diagram, a function could process an API call and then store the process data in Cosmos DB. And once the data transfer happens, another function could trigger a notification. You see that? Yes. Now, this is about the functions, and now we need to consider certain things. Like what? Like large or long-running functions can cause unexpected timeout issues. Whenever possible, refactor large functions into smaller chunks of code and return responses faster because it's a small chunk of code. The default timeout is 300 seconds for consumption plan. However, 30 minutes for any other plan. As I said at the beginning, there are multiple ways we can run the functions. Now, durable functions let you write stateful functions. Yes, it's not always stateless, stateful. That's a thing now. with the help of durable functions. So behind the scenes, the function manages the app state, checkpoints, and restarts, because somewhere it has to manage, and function is just a piece of code. So behind the scene, it does. An example application pattern for durable function is function chaining. What's that? Well, function chaining executes a sequence of functions in a specific order. The output of one function is applied to the input of another function. Okay. Now, consider how you want to group functions with different load profiles. For example, let's say you have two functions. One function processes many thousands of queued messages and has low memory requirements. The other function is only called occasionally but has high performance requirement. So you might want to deploy separate function apps so each function gets a own set of resources. Separate resources mean you can independently scale the functions, no dependencies. The same logic applies when you run multiple application in a same one app service plan, like CPU intensive or memory intensive. So one scale at the back end, all those instances will be scaling, and all the applications are running on that would have multiple replicas, whether they need it or not. So you need to organize functions for performance and scaling. Okay, let's see what else. Well, design your function assuming an exception could occur at any time. Downstream services, network outages, or memory limits could cause the function to fail. So plan out how you continue from a failure point. So we need to write a function in a defensive mode. Okay, then when you create a function app, you must associate it with a storage account. To maximize performance, use a separate storage account for each function app. This is important if your function generates a high volume of storage transactions. So avoid sharing storage accounts. These are the design considerations that we keep in our mind. Now, we talked about hosting a function. There are multiple ways. So there is one more. We must choose a hosting plan for our application. The plan we choose has an effect on performance, reliability, and cost. Just like basic, standard, premium. So with the plans, the features, the benefits increases. So yes, availability increases, reliability increases, and of course, cost as well. So there are three basic hosting plan available for functions: consumption plan, premium plan, dedicated plan. All hosting plans are generally available when running either Linux or Windows operating system. The hosting plan we choose determines behaviors, couple of behaviors as per their features. For example, scalability, instance allocation, resource availability, or advanced functionality such as virtual network connectivity. Well, these are some best practices, design considerations for this Azure Functions, and I hope it was fun. And thank you for watching. You guys have a good day.